Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Mr. Cheka welcoming you all to yet another video for my grade 11 advanced math students. So we are going to begin where we left last in the video. So we are still on EOT, Learning Objective 1. And in this session, as promised, we will be covering question 33 and 34 from page 222 in this session of today's video. So let's get started and learn how to see and how to graph exponential growth functions. This part of the video is going to cover some of the most important questions that are going to help you for your coming math exam. So make sure you watch the video till the end. And if you like the video, give it a thumbs up and share with your friends who will benefit from the same. So let us first understand what question 33 is asking us. So here in this question, you are given one function fx. The graph of this function is not given to you, and that is what you need to do in part A of the question. But yes, you are given another graph, which is the graph of gx. So in this question, you have two functions, fx and gx, coming together. And your work in this question is to compare their features. So we are going to first go ahead and do the graph of fx, and once we get the graph, we are going to compare the two graphs and look at their key features. So if you read part B of the question, it is asking you for so much information. It is asking you for domain, range, intercepts. It's asking you when the function is increasing, when the function is decreasing, where it is positive, where it is negative, what are the minimum, what are the maximum, does the graph have symmetry, and also it is asking you to compare the end behaviors of the two function fx and gx. So let's go step by step. It's a long question, very important, and this is one of the most requested videos that has been asked by my students of grade 11 advanced. So I'm going to be doing this in great detail. I need your attention and focus. So let's get started. And as you know, in your ministry exam, you're not allowed a graphing calculator. So the only way you will proceed with the graph is to use your scientific calculator in the right manner and go ahead and make the table of values. So let's make a table of values for our function fx, and for that we are going to make a table. We will have two columns in it, one column that will have the values of x and the second column that will get us values of fx. So keep your calculators ready and let's take some values. Now, before we go on and proceed with the table of values, we need to look at the function very carefully. Those who have been studying from me, they already know that this is a piecewise function. Why? Because it has two pieces. This is the first piece, this is the second piece. Now, if you look at the first piece carefully, it is an exponential function. And we've already discussed what are the two types of exponential functions. So this one has a base 3 divided by 4, which is 0.75. So it's less than 1. So this is an exponential decay function. So even before we draw the graph of this function, we know that when x is going to be less than 0 or x is going to be negative values, the function is going to be decreasing in nature. It's an exponential decay function and the base is 3 divided by 4. Okay, that's a good way. So that's one part of the piecewise defined function. The second part, if you observe, is just like a very normal linear function. So how is this function defined? If I take y, fx is just like y. So y or fx, whatever you use, is equal to 3x plus 1. So I hope you all are able to relate this to y equal to mx plus b, and you get to know that this is a linear function. So this part of the graph, for what values of x? The values of x are given here, positive, greater than equal to 0. So when your x is equal to 0, when your x is more than 0, like 1, 2, 3, the graph becomes linear. So this is a piecewise defined function where one part of the graph is exponential and the other part is linear. Okay, now we are ready. So let's find these values. So if you see, this is the slope intercept form. So here the slope, which is given by rise over run, is given by 3 over 1. Yeah, so we rise by 3 units, we run by 1 unit. And b, which is nothing but your y intercept, and we're talking about fx right now, is given to be 1. So we know the graph of fx is going to touch the y-axis at the point 0, 1. And then we'll further use the definition of slope, which is rise over run, to graph this part of the function. Okay, let's come to now the table of values back again. So we are going to first make the table of values for negative values, because at negative values we have an exponential decay function. So let me start with -5. Now some of you might be thinking why I chose only this point. And if you would have seen my previous videos, you are quite aware that when we are doing the graph of an exponential function, we take at least bare minimum 6 points. So I start with -5, then I decrease -4, -3, -2, -1, and I stop at 0, because after 0 I know the function is turning to be a linear function. So I need not take table of values, I can straight away do the graph. Okay, so let's find. So now it's time for you to put in your calculators. Just plug in this function 3 by 4 to the power x and put your x value as -5. So I'm sure you are getting a value close to 4.21. Similarly, do it for -4, plug in, and you'll get something close as 3.16. Next is 2.37. Next is 1.78. Next is 1.33, and finally at 0 the function becomes 1, and that's what is your y-intercept. Okay, well defined. Okay, so now we are ready to do the graph. So let's do the part A. I'm doing it freehand, so it will not be as straight as what you will get when you use a ruler and a pencil. Make sure your divisions are correct when you're doing the graph. Let's make the partitions. Okay, positive x-axis, negative x-axis. Assume that my partitions are of equal dimensions. So this is positive, negative, y-axis. Okay, perfect. Now let's go first to this part, because it's very easier to graph a linear function as compared to an exponential function. So we'll graph 3x plus 1 before we do the exponential part and use the table of values. So I'm going to go to this point, which is the y-intercept 0, 1. I hope you all know that when x is 0, the point lies on y-axis. So this is my point 0, 1, and now I use the definition of slope. Slope is rise by 3 units. So when I rise by 3, 1, 2, 3, I reach this point. This point is 0, 4, and then I run by 1 unit. So means I go in this direction. Now see, both these values are positive. So when I say rise by 3 units, I'm going up. And when I say run by 1 unit, I'm going in the right direction. So this is my new point. So what's the coordinate of this point? X is 1, y is 4. Wonderful. So that gives us the 2 points. Now we are ready to join these 2 points using a straight line. And this is the linear part of the graph that corresponds to 3x plus 1. Perfect. So we've got the linear part. Let's now move and go to the next part of the graph, which is going to be exponential in nature. Now look here carefully. The exponential graph also has the point 0, 1. So that means it's going to end here, and because we know the base is less than 1, it's going to be decreasing. So therefore I'm now just putting this part of the graph exponential decay for you. So it's going to be decreasing and joining this point. Okay, so this part is 3 by 4 to the power x. So this is how the graph of fx looks like. And as you see, fx is a piecewise defined function. One part of it is exponential while the other is linear. Now we are ready to do the part B of the question. And for that, because we are doing a comparison question, I would urge you to make a table of difference while you are doing this comparison. So we are going to compare these two functions now, the graph of fx and the graph of gx, on these bases like domain, range, intercepts. And when I say intercepts, it's going to be both the intercepts, x-intercept and y-intercept. Okay, next is we are going to compare which one is increasing, which one is decreasing. At what intervals is the graph positive, At what intervals is the graph negative? Where are we getting the minimum maximum symmetry? And then behavior. Now if I pick out of all of these options, then the easiest one to rule out for me is symmetry. As you see, both these graphs, whether I pick up fx, whether I pick up gx, both are not symmetric. So this is a common point for both. Both share the same thing, both are not symmetric. And yes, I would also like to talk about the end behavior on this slide only, because here we have the graph, so it will be easier for us to get the end behavior. So let's look at the graph one more time. I'll begin with fx here. So this is my negative x-axis. This is my positive x-axis. And if you see this part of the graph, the function is going up. So I would say for end behavior, as x goes to minus infinity, where is my graph going, fx? Yes, you're right, it's going up. So it goes to positive infinity. Wonderful. Let's move to the other part. For this part, fx, we are moving to the positive side of the x-axis. So x will go to plus infinity. And where is fx going? Again, it's going up. So still here, it's going to go for plus infinity. Now, I made the assumption here that x is negative, here x is positive, up y is positive, and below y is negative. So we are following the basic coordinate axis sign convention. Okay, let's do it here also. Now, the end behavior here is a little different for gx because gx is a perfect exponential function. So therefore, at this part of the graph, the lower part, you could assume that there is an asymptote. So this part is asymptote, and if I look at this coordinate, it is -1. So that means the equation of asymptote is y equal to -1. Now, I hope you remember from my previous video that asymptote is a line that the graph just approaches. So if you look at this part of the graph, it seems like that this part of the graph is near about coming very, very close to the asymptote, or in fact touching it. Okay, so it will not exactly touch, but it will be very close. So at this part of the graph, you are getting an asymptote. Now, from the asymptote comes your end behavior. So left part of the graph, where x is going to minus infinity, the graph of gx is going to -1. So gx goes to -1. And up this side, where x is going to plus infinity, gx is going to plus infinity because it's going in the positive direction of y-axis. Okay, so we've discussed some important points. Let's proceed to the next slide and make the table of difference in order to compare the two functions fx and gx in a nice organized way and look at their key features and compare them in the right way. Okay, so let's now complete the question and do the part B where we are going to do the comparison. So as I told you, we are going to make a table of comparison. That's a good way of answering this question, and it becomes very easy for your teacher also to check once we are doing in that manner. Okay, so let's write the two functions. So the first function is fx, make a table. The second function is gx, complete the table. Now one by one we are going to write the points which we are comparing for these two. So first point that we are comparing is domain, then range. You can number it 1, 2, then 3. Now intercepts are again two types, x and y, then 4, then 5, 6, 7, 8, 9, 10, and 11. So like that you number the points and then you put the points here one by one. So I'm putting first domain, then I'm putting range, then I'm putting say x-intercepts, then I put y-intercept, then I put increasing, then I put decreasing. Now I have less space here, so I'll not be putting the end behavior in symmetry. We've already discussed in the last slide. So we can proceed with positive, negative, and in a similar way you can proceed and do minimum, maximum also. Now I've kept both the graphs here. This is gx, this is fx side by side so that it is easy for us to compare on these points one by one. Okay, so let's begin and let's fill the table. We're going to put domain here and range and so on. So just make a table of comparison like this. If you present your answer in this way, there are two benefits. One, you save your time. Two, your answer is organized and it becomes easy for the teacher who's checking your paper to clearly see what you have written, okay, without wasting much time in writing complete sentences. Okay, so let's see now domain. So domain, remember, comes from the x values or the x-axis, while the range comes from the y value or the y-axis. So here this function, the blue graph for gx, let's see gx first, is taking negative values, it is also taking 0, and it is also taking positive. So yes, it is taking all real values. So I will write in interval form minus infinity to infinity. Now this is a way which saves your time. You can also write real numbers, or if you have more time in your exam, then you can write the full sentence, all positive real numbers. Both are correct. Okay, so I would advise you to write the correct information in the minimum number of steps, which are very, very important, not to miss the important information. So that will save your time. Okay, next is range. Range comes from the y-axis. Now, if you see a gx, we already talked in the previous slide about its asymptote. So asymptote is at -1. And if you see this graph, the blue graph of gx is always above y equal to -1. This is in fact like a minimum point for this. So we could easily say that the range for gx is always going to be more than this -1 value. Now it cannot be equal to -1 because at -1 you are getting the asymptote. So the function of gx is not defined at that point. Okay, so it has to be a strict inequality greater than -1. Let's come to fx now. So for fx, this is definitely the minimum point, and it is nothing but the y-intercept also of the point. So 0, 1 is the coordinate. So we could say that the whole part of the graph is above this point. So if I again draw an imaginary line at y equal to 1, then the whole part of the graph is above this y value. So definitely the range for fx here would be y greater than equal to 1. Now equal to 1 is included because we don't have any asymptote here for fx. Wonderful. Let's proceed and now look at the x-intercept. So x-intercept for gx, it is meeting at 0, 0. So either you write, here 0, 0, or you write 0. Both are going to be perfectly correct. Now look at fx. My question to you is the graph of fx meeting the x-axis? No, not at all. So there is no x-intercept, or you can just write none. Okay, so this is how we are comparing each of the points one by one in a tabular format. Very, very organized, not to miss any information. Okay, let's proceed. Now for y-intercept, where is this graph of gx meeting the y-axis? Definitely it is meeting at the same point, which is your origin. So 0, 0, or 0 is my y-intercept for gx. Let's come to fx. For fx, again, the same point is there. So the y-intercept is going to be 0, 1, or simply 1. Okay. Okay, then. Now we need to look at both the graphs one more time and tell where the graph is increasing, where it is decreasing, where it is positive, where it is negative. This is very, very easy. You can just look at the graph and understand about this information. So let's do it one by one. So fx, let's do it first. So fx is increasing when x is positive. Definitely you can see here when x is having any positive value, like this part of the graph is increasing, right? So when your x is positive, your fx is increasing. What about gx? Can I say even for negative value of x, the graph is still increasing? Even for this part, it is increasing. So therefore, gx is increasing for all values of x. Okay, now let's come to the next part, decreasing. So fx is decreasing where? It is decreasing in this negative part where you have the exponent, this part. So this part of the graph where x is less than 0, you would say fx is decreasing. However, for this one gx, because we already spoke about gx being always increasing, so there is no value of x where the graph of gx becomes decreasing. So it's a increasing graph. Okay, let's talk about positive. So just remember, a graph is positive when the values of x are above the x-axis, and it is negative when it is below the x-axis. So we are going to use that concept, we are going to use that logic for completing this part of the question. So we could just say that fx is going to be positive for all values of x. Now think about why I say this, because there is no part of the graph of fx which is below the x-axis. So this function fx is always positive, therefore it is no value of x where the graph of fx is negative. What do you say about gx? See, in gx there are two parts of the graph. From here to up it is positive, from here to below it is negative. It's as easy as it looks in the question. So we can say that for gx, the graph is positive when x is greater than 0, and it is negative when x is less than 0. Okay, now I don't have space here to write, but I will quickly discuss on minimum and maximum also, and then in the next slide I will show you the complete answer. So here fx has minimum. If you see at 0, 1, this is very much evident, so this is the point of minimum. And if you look at gx, then gx has a minimum at -1. Okay, so that's minimum. Let's go to maximum. So for maximum part, I would want you to think how it is to be done. Does it have a maximum gx? That's my question to you. Does it have a maximum fx? That's my question to you. Think about it and I will show you the answer in the next slide. Okay, then we are done with everything. We already discussed both graphs are not symmetric, and we also looked at their end behavior. So now everyone is ready to look at the complete answer for question 33. So let's have a look. Okay, so this is how the final answer looks like for question 33. I've shown here in nice detail how to make the table of values. This part of the slide looks at the question for part A, where you do the graph and do the comparison. And this is how you have to represent the second part of the graph. Now see, in your book, the answer is given in this way for part B. Where you do the comparison. So this is very, very lengthy. It is very confusing. It's not direct. So I would suggest you not to use this method and take my method. It will save your time. It will be easy for you to write, and it will also be easy for the teacher to check. Okay, so even though both answers are correct, but this is like a paragraph form, which is not very much advisable when we are doing a math question. So make the table of comparison and it will surely save your time. Now, in a similar way, you can also try doing question 34. It is exactly the same method that we are going to use. If you see here, only the numbers and the graph is different. But if you understand the logic, how we did question 33, this will be very easy for you to solve. So I would urge you to try this out yourself. Again, as I told you in the previous question, this is a piecewise defined function. Go ahead, make the table of values, get the graph for part A, and then further in part B, do the table of comparison and compare the two graphs, one of fx that you get and the one of gx, which is already given here to you. Make the table of comparison and get your answer. Let me show you the correct answer now. Okay, so those of you who would have solved the question yourself in a very similar way would have got the correct answer. So this is the table of values that you would have made for negative x values, and this is the graph of fx that you would have got in a very similar way. Again, this is the graph of gx. So for part B, we are doing the table of comparison, where we are comparing all these points as we did for question number 33. So I hope you've solved the question yourself and now you're ready to check your answer. So let me show you the final answer for question 34. Okay, so for this question, for part B, this is the answer given as per your book. But again, as I suggested you, it will be better to save your time and to organize your answer to make the table of comparison when you are doing the part B of the question, and make the table in a nice organized way where you are comparing the graph of gx and the graph of fx over these key features one by one. So that completes this video where we learned how to compare two graphs and to see the table of comparison of their different key features. With that, we have come to the end of today's video. This video completes your learning objective 1 for all my grade 11 advanced students. So if this video helped you, I would request you to give it a thumbs up, share with your friends. And for more such content, don't forget to like, share and subscribe to the channel and press the bell icon so that you receive notification of all my new videos coming up, especially for your grade 11 Math Advanced revision. All the very best. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye, students.